right, let's do number 5 through 8. We need to solve this equation, and they want us to solve it for all x. The fact that it's in x means we're going to be answering in radians, okay? When I look at this, they have just the sine function, but I see that this angle is 2x and this angle is x, so not the same angle. Is it possible to rewrite everything in terms of x? Yes, it is, because there's an identity for the sine of 2x, but it's 2 sine x cosine x. So when we do that, we will introduce a cosine, but maybe that's not a problem. We're going to try it and see. So let's see what we can do with that. Let's rewrite this guy so we have everybody in terms of x. The identity for the sine of 2x is 2 sine x cosine x is equal to 2 sine squared x. Can this factor? Well, they both have a sine x in them. So if I get a 0 on one side, I can factor this. So that's good. I'm going to move everybody to this side because I like a positive leading coefficient. So I'm going to subtract this term. I get 0 is 2 sine squared of x minus 2 sine x cosine x. Now, a 0 on the left is the same thing as a 0 on the right, but I am not comfortable with it on the left. So if you don't like it on the left, you can put it on the right. That's called the reflexive property. And so I'm going to take advantage of that because that makes me feel better. I'm going to factor out my common factor of 2 sine x, leaving me with the sine x minus cosine x. And this looks similar to a problem we already did. Let's set this equal to 0. This factor, 2 sine x is 0. Divide both sides by 2. The sine of x is 0. Whenever this is true, this equation will be true. Set sine x minus cosine x equal to 0. And that will be true when set sine x minus the cosine of x equal to 0. And this will be true when the sine of x is equal to the cosine of x. This is similar to one we had before. Here's our unit circle. We're going to think about this one. When is the sine 0? The sine is 0 right here and right here. And since this is in terms of x, I'm going to call this angle 0 radians and pi radians. That's 2 answers I got right there. When is the sine equal to the cosine? That's at the 45s or the pi over 4s. But only when they have the same sign. They have the same sign in quadrant 1, positive, positive at pi over 4, and in quadrant 3, this is 7 pi over, is that right? No, that's not 7. This is 5 pi over 4. So those are my 4 answers if they said from 0 to 2 pi, but they did not say that. They said all x. We have to list all of them. Again, this particular problem, the 0 and pi, if you add pi and add pi and add pi and add pi, you're going to keep going back and forth between these 2 answers. So we can answer these 2 answers very simply with pi times k, where k is an integer. We already discussed how we're agreeing to that. So this is one of my answers. X is this, okay. What's another one? X is pi over 4. And then if I add pi to that, I'll get here, and if I add pi to that, I'll get here, and this is off by pi. So if I say plus pi k, that will capture those. So that's a nifty way to answer all of the answers for number 5. Okay, great. Let's go over here to number 6. What is the deal? Well, let me check my answer, make sure I didn't make a mistake on 5. Yes, that's okay. Okay, number 6. This one is a little bit different because we have 2 different angles. In this case, we had 2 different angles, x and 2x. So we have 2 different angles. Here, we have theta over 2 and theta. Now, we have seen a half angle before on that secant problem earlier, but that was the only thing, that was the only trig function involved. Here, we have more than one trig function involved, and we have a half angle. I don't like to use the half angle identities if I can help it, because when you're solving equations and you have to square both sides of an equation, you introduce what's called extraneous solutions. You may recall that from long ago when you were solving radical equations. So if you square both sides of an equation and you solve, you have to check your answers, because sometimes it introduces things that look like a good solution, but once you check them, they're really not. And I don't really want to go through all of that. So by choice, I'm going to handle this by introducing a new variable. You don't have to do it this way, but it's a good way to do it. The book has other ways you can look at, but I'm going to let this half angle, I'm going to introduce another variable, and I choose to call it m. You can call it whatever you want. I'm going to let m equal to theta over 2. And then I'm going to multiply both sides by 2, and I get that 2m is theta. Then I'm going to rewrite this equation in terms of angle m. What will that look like? Over here, this will be the cosine of m is equal to the cosine of theta, but theta is really 2m plus 1. Okay, now if you think about that, I've got another equation with 2 different angles in it. Why is that better? It's better because the identities that involve double angles do not have square roots in them, and so we don't introduce extraneous solutions. In fact, we have used that here very nicely, and it didn't cause any problems at all. So let's see, let's use a half angle identity for cosine. For cosine, there's choices, right? There's a few different choices that we could use. I'm going to choose one that rewrites this in terms of cosine. So the identity for the double angle for the cosine of 2 times an angle is going to be 2 cosine squared of that angle m minus 1 plus 1. So this part is the substitution. There was choices. I didn't really want to use the 1 minus 2 cosine squared of x because that would give me, that's true, but it didn't help me because I wanted everything in terms of cosine. So this one helped me, and this is the one I want to use. So let's proceed here. I need some more room, so I'm going to erase part of this problem. Over here, what I'm going to do is collect like terms. So this is the truth, whether you're in trig or algebra or whether you're walking down the street. If you have a parentheses and on the outside of that parentheses you don't see anything, there's a positive 1 right there. And that's what's holding it on the board. If it were not a positive 1, you would see what it was. You would see a negative indicating a negative 1, a 2 indicating a 2, a 1/2 indicating a 1/2. But if you don't see anything, it's a positive 1. And if you have a positive 1 on this parentheses, you don't actually need them. So these are free to be collected like terms. -1 plus 1 is a 0. So when I rewrite this up here, I'm going to leave that part off. This is simply cosine of m is equal to 2 cosine squared of m. All right, I'm going to get a 0 on one side and factor this. So I'm going to get a 0 on the left side. 2 cosine squared of m minus the cosine of m. Again, I don't like the 0 on the left, so I'm going to put it on the right side. You're allowed to do that too. I'm going to factor. What can factor out of this? A common factor of the cosine of m, leaving me with 2 cosine m minus 1. So let's solve these for m. When will the cosine of m equal to 0? When will 2 times the cosine of m minus 1 equal to 0? When the cosine of m, add 1, divide by 2 is this. Let's look at our unit circle. Where is the cosine 0? Right here and right here. So this will be when m is, what did this start in? Theta. So let's talk in theta. When m is 90 degrees and when m is 270 degrees. All right. When is the cosine positive 1/2? Right here and right here. And this is 60 degrees and this is 300 degrees. So those are our answers for m. But we're solving for theta. So at the very end, we go in and solve for theta. So I say 2m, theta is equal to 2m. So theta is equal to 2 times 90. Theta is equal to 2 times 60. Theta is equal to 2 times 300. Theta is equal to 2 times 270. And so my answers here are going to be 180, 2 times 90, 2 times 60, 120. These are not in order, but that's okay. 2 times 300 is 600. 2 times 270 is 540. So I could do a better job listing these in ascending order, but it's okay, it's still a list. Are we in the interval? All of the angles between 0 and 720, and these are. So I kind of helped us out a little because I wanted it to be easy, so I gave us that interval. But that's how we would do that one. All right, let's do 7 and 8. 7 is 2 sine x is cosine of 2x. We can handle this. We can rewrite cosine of 2x into terms of sine, and then we can factor. We can do this. This is kind of old at this point, but that's our plan. What identity of the cosine of 2x should we use? The one with sine in it. So let's do that. This is 2 sine x is equal to, let's rewrite him into 1 minus 2 sine squared of x. 1 minus 2 sine squared of x. This is just using a double angle identity. Then I'm going to get a 0 on one side. So I'm going to move these guys over here. If I add this to both sides, I get 2 sine squared of x plus 2 sine of x. And if I subtract 1 from both sides, this is what I get. Now, it would be awesome if this factored, but it doesn't. So that means I have to use a different method to solve. Again, if the trig functions are getting in your way, rewrite it just in terms of with the x's. You could call this 2x squared plus 2x minus 1 is 0. And this is where x is equal to the sine of x. Maybe I should call it something else because we have so many x's. Let this be w, where w is equal to the sine of x. Okay, so we can solve this. If it doesn't factor, see, factoring's so easy, but if it won't factor, we have other methods. You can complete the square, everybody's very favorite, or quadratic formula is a good one. I'm going to use quadratic formula. This is quadratic formula. X is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And this is for a quadratic function that looks like this. So I'm going to do that for this. W is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this is going to be negative 2 plus or minus the square root of 4 plus 8 over 4. Or negative 2 plus or minus the square root of 12 over 4. You can simplify this this will simplify into negative 1 plus or minus the square root of 3 over 2. If you rewrite this as 4 times 3 and factor out the 4 and then cancel the 2 in the numerator and denominator. But even if you leave it in this form, we got to go to our calculator because they said go to 4 decimal places. And make sure your calculator's in radian modes. So when you put this in your calculator, this is 2 answers. We have negative 1 plus the square root of 3 divided by 2, negative 1 minus the square root of 3 divided by 2. When you put this in your calculator, negative 1 minus the square root of 3 divided by 2, you will get a negative number that is below negative 1, something like negative 1 point something, which means this is outside the range of the sine of x. So, because that only goes between 1 and negative 1. We will not get any solutions from that guy, so reject him. Put this in your calculator, and you get this decimal looking thing. And then when you take the inverse sine of this guy, you get that x is equal to 0.3747. This is, and they wanted it to 4 places. So this is the radian value of the angle that has an inverse sine of this number. So this will solve this equation. Now, what was the interval from 0 to 2 pi? So we got to think about this. Here's one answer. Where is 0.3747? I don't know exactly, but I know it's in quadrant 1. These are radians, right? This is 0, this is pi, 3.14. This is 1.5 something. So it's between here, it's in quadrant 1. So if we go around the unit circle, there will be another answer we can get that has a sine value, a y value of that, and it's going to be here, because here are the 2 y values where it's the same. So this is what this one's equal to. How can I obtain this answer? Is I can take pi minus 0.3747 0.47 is how I can get this answer. So when I do that, my second answer is going to be x is equal to 2.7769. All right, so that's how you can get that one. All right, number 8, then we're done. This is in theta, so we're looking for degrees in our intervals just from 0 to 90, and they want this to 4 decimal places as well, but this is going to be in degrees. So this time make sure your calculator's in degrees. This is, when we look at this, these are all in terms of sine. So yay, that's good. They are in the same angle, theta, that's good. This is basically ready to be solved. I need to get a 0 on the right-hand side first. So I want to first subtract 6 from both sides, and that's going to give me 6 sine squared of theta plus 5 sine theta minus 6. Is 0. Now, I would totally try to factor this, but I tried and I couldn't get it to work. So now, oh no, I tried and I think it might have worked and I didn't. Maybe I didn't try hard enough. Let's see if this factors. 6 times negative 6 is negative 36. All right. We want two things to add up to be 5 and to multiply to be negative 36. All I can think of is a 6 and a 6, but this is a 3 and a 2, and this is a 3 and a 2. What about 9? What about a 9 times 4? Oh, what about a 9 minus 4? This does factor. 9 times negative 4 is negative 36. 9 plus negative 4 is 5. So when I was working this out earlier, I used quadratic formula, but it will factor. Let's factor this guy. So let's get good at this. If you get tired of the trig functions, let's let x equal to, or w, let's go with w. Let's let w equal to the sine of theta. Then this is 6w squared plus 5w minus 6. If we want to factor this guy by, rewrite this middle term, AC method, 6w squared plus 9w minus 4w minus 6. Group the first two, group the second two. By the way, I'm so pleased as I'm grading your second test. I see people factoring their trig functions so beautifully. Factor out common factor of 3w, leaving me with a 2w plus 3. Take that negative and anything else that will go, a 2 will come, leaving with a 2w plus 3. Let's see, that's negative 4w minus 6. 6w squared plus 9w. Yep. This is 3w minus 2 times 2w plus 3. Let's see. 6w squared minus 4 plus 9 is 5 minus 6. This is factored correctly. Good. W represents the sine theta. So when I solve for w, I get that w is equal to, I'm going to add 2, divide by 3, 2/3. Okay, so I'm going to get that. The sine of theta is 2/3. And when I solve for this, I'm going to subtract 3, divide by 2, and I'm going to get that the sine of theta is negative 3/2. I'm going to reject him because negative 3/2 is negative 1.5. That is outside the range of sine function. I will get no answers from him. Sometimes that happens, not every time, but it did happen twice in this. But you just check every time. This is inside the range, so we'll take the inverse sine, and we'll get that. And we're in degree mode, right? Degree mode. And so when I take the inverse sine of that, I get 41.8103 degrees. Why am I taking this out so many digits? Because they told me to. So this time, where's 41 point something? About right there. Is there another place that the sine would hit this? Yeah, over here, right? This is the same y value. However, I only have to list this guy because of the interval. They only wanted me to go to 90. From here to here is 90, and this guy never even makes it in the interval. So that's the only one I have to talk about. So this is the middle video. We just have one more to go, and you guys will be through this section.